Day 110. Let's see here. Today's purpose, you will practice the skills that we've learned so far, the relevance. So we have our quizzes next week. Day 111 and day 12. Let's see, for this year that's going to be next Tuesday and Wednesday. Success, you're going to be having questions very similar to your homework today. And that'll be on the quiz style. Okay, so main ideas. Natalie, would you please read number 1?
We did a lab where we modeled the sun shining on a beach lake. The beach warmed up more quickly than the water.
And Javon, number 2. Let's see, Alejandra? Riley, number 3.
The sinking and pushing of cool air causes ice convection current to develop. Air moves from the cooler water onto shore. It might extend a few miles from the water.
And let's see here, Tyler, number 4.
Number 4. At night, the sand cools off faster than water. The air above the land cools faster than the air above the water. A convection current helps the convection current develops that is opposite the daytime current. Air moves from the cooler land down to the water.
So let's draw a picture of these different concepts. Number 1, draw a convection current set up at a land breeze at night. So everybody please draw some water and then the beach. And then we can have a house and a tree or whatever you want. Go ahead and draw a scene like that, please. I have new packets down here if you want to grab one. Okay, now at night the land is going to cool down more than the water. So this is going to be cooler than water. The water is going to hold on to the heat better than the land. It's going to be at the very bottom.
Yeah.
So the water is going to be warmer than the land at night. Oh, let's just say that the water is 74 and the land is 72, something like that. I'm just making up numbers. So that means that the air above the water is going to be warm air. And above the land is going to be cool air. Warm air rises. Cool air sinks. And the cool air is going to sink and push up the warm air. Warm air by itself does not rise. It has to have cooler air that's just sinking and pushing the warm air up. But in our society, the phrase heat rises has won out over coldness sinks. It should have been cold sinks. That would have been better. But, oh well, we say warm air rises and that's fine. And so we set up the convection current then like this, going around and around and around. And if you are a person standing right here, you're going to feel the air coming from the land, from the city, out to the water. That's called a land breeze. Now let's draw the opposite going on during the daytime. We have the water and we have the land. We have our house. We have our tree. Oop, thank you very much. I'll always yell that out if I need to. Okay, now during the daytime, the land is going to heat up more than the water. So the land is going to be warmer. Maybe it's going to warm up to, let's say, 78. And the water is only going to heat up to, let's say, 76. So the water is cooler. It did warm up some during the day. You know, the sun shining on it does make it warmer, but not as warmer as the land is. So now the air above the land is going to be warm air. The air above the water is not going to be as hot. It's going to be cooler than the land. So now the warm air rises, cold air sinks, and we get our convection current that way. If you are standing here on the shore, you're going to feel a cooler breeze blowing at you from the water side of things. Once again, this is at nighttime. I'll draw a moon. This is during the daytime. Draw the sun. The water is heating up. So this warmer and cooler is not talking about increases. It's just saying that here the water is cooler than the land is. And here the water is warmer than the land is. The land is swinging back and forth at greater degrees than the water is. Okay, enough of that. Next page. How would our results in yesterday's project change if we used a regular 60-watt light bulb? In your lab yesterday, we had a 250-watt light bulb. Imagine doing it with only 60 watts. How would that change the numbers that you got? The temperature numbers. Chandler, what do you think? Let's put the phone away, folks. I'll come back to you in a second, Chandler. Let's see here. How about Ty? Riley? If we used a smaller light bulb, we were going to have less heating. We would have lower temperatures. Number 4. Suppose a group of students finished our lab yesterday and then went on to do another similar experiment. They had the light shine on a 50-gram piece of asphalt, a 350-gram pile of brown pebbles, and a 400-gram pile of white gravel. The data they took is shown. So lots and lots of data. Some of this data is irrelevant and can be skipped, omitted. Please close up your laptops at this time and let's focus on the science on the screen. Some of the stuff you can ignore, some of it's important. What conclusions can you draw from this data? There are all different kinds of conclusions you can make. Look at, we have time increasing up to 10 minutes, just like yesterday's. Light status, whether they have it on or turned off. Current being used by the light bulb. The brightness of the light bulb stays fairly consistent, then it turns off. And then the temperatures going up and then going down. Another temperature going up and going down. Another temperature going up and then going down. What conclusion can we draw? Sierra? Parnell? Well, the real differences here are in the last 3. We have the, let's see here, the very dark black asphalt. We have brown pebbles, and we have white gravel. So as we go from here to here to here, we're getting lighter and lighter colors. Asphalt's basically black, and a lighter color brown, and then lighter white. And we can see that the temperatures that they achieve are getting lower and lower as we go to lighter and lighter colors. So we could say that lighter colors don't heat up as much. And you've had experience with things like cars and all of that. Please put away your phones at this time. Next page. Classwork. Instead of me lecturing about this and yakking, you guys please be quiet. You guys please be quiet. Hey guys, please be quiet. Instead of me reading all this and doing it as a lecture, you just transfer words. Word number 1 and blank number 1 is heat. Please put that right here in the first blank. Blank number 2, put core. Blank number 3, put currents. Do it at your own pace. Please be sure that you're reading the sentences as you are writing down the words. Don't just copy words, that's meaningless. Read the whole sentences that result. At the bottom, review, draw a diagram of the 6 convection currents around Earth. So where we have the sun shining directly onto the equator, it gets the ground warm, which gets the air warm, and warm air rises. So please draw an arrow like that. And this is going to split when it gets high. It's going to go some to the north and some to the south. After a while of being up high, it's going to cool down and it's going to sink. And so there we have the first convection current on the north side of the equator. It's going to drag other air down, and some of that air is going to go towards the north. That starts off a second convection current. At the very far North Pole, we have very cold air. It's going to sink. That sets up a third convection current. We have these two masses of air moving towards each other. They're going to collide and push each other up. And so then we have the full convection currents, a total of 3 on top. And the exact same thing happens at the bottom. Notice how the arrows alternate. Here, this is going counterclockwise. This is clockwise, counterclockwise, clockwise. And so there we have our 6 convection currents. These happen on the other side as well. In fact, this convection current right here is like a donut that goes around the Earth. So we see the right-hand side of the donut, and then there'd be one on the left side of the donut as well. Same thing for all 6 convection currents. Questions about that? Okay, for the remainder of the period, I'm sorry I don't have that much for you. I only have this short homework assignment on page 61, and that's it. So if you have other work that you have to turn in yet, please check your grade book, and you can spend lots of time today getting all caught up. I'm going to be putting in zeros for everybody's missing assignments, and so your grade is going to be going down a little bit during the period, but please check to see which ones you can do to make that up.